Okay, so in previous videos, I've talked about different sea levels, like in the past when they were lower and also how they could be higher in the future. But today I want to take this to an extreme. What if the Earth had way more water? Like I'm talking more than even if all the ice in Antarctica and Greenland melted to the point where only the highest areas remained dry. What new landmasses would take shape? What sorts of environments would there be? How would life adapt to a world like this? And perhaps most importantly, what new insights can we gain by looking at the Earth in this way? All of this and more is what we're here today to find out. Okay, so I figure before I get started, I should just say that any sea level I chose for this was going to be arbitrary. If all the ice on Earth melted, sea levels would only rise by around 70 meters. But to be honest, this doesn't really alter the layout of the planet all that much. So we're going to need more water than the Earth even has. Ultimately, I chose a height that I thought had the most interesting geographical implications for our world, and also could teach us the most about its underlying processes. The amount of sea level rise I picked was 2,000 meters, as it's a very clean number, and it's also at this point that the world is reduced to two final continents, the Andes Mountains in South America and the Tibetan Plateau in Asia. Together, these two regions represent the most significant mountain building events the planet is currently undergoing. But before I get to talking about these individually, first I'd like to compare them against each other. Built off the higher of the plateaus, of course Tibet forms the larger of the two landmasses, but what I'm really interested in is their differences in shape. While Tibet appears like a lumpy, irregular mass, basically the same as our continents do now, the Andes stand as one long, narrow stretch of land, quite a different arrangement than anything above water today. And this difference in structure is actually a very direct translation of the differences in how these two mountain ranges were formed. Tibet, as we should all know, was built up as a result of the Indian subcontinent colliding into Asia, forming a convergent plate boundary, giving it a more chaotic or random arrangement, akin to the random conglomerations we call continents. The Andes, on the other hand, formed via a subduction boundary, where an oceanic plate is forced beneath a continental one. As the plate re-enters the mantle, the water and gases absorbed into the rock melt into less dense magma, forcing it to float back up, fueling a string of volcanism several miles away from the true plate boundary. This mechanism for construction means the Andes directly correspond to the path of their tectonic boundary, which in most cases, including this one, is more or less a straight line. The closest analog I can come up with for a similar landmass was ironically created as India broke away from Africa. The ocean floor ahead of the subcontinent was forced into subducting beneath Asia, fueling another chain of volcanism that produced a similarly linear landmass called the Dras Volcanic Arc from around 170 million years ago until about 50 million years ago, before it was rammed by India itself and forged into Tibet. Overall, the differences between a convergent boundary and a subduction boundary explain why we end up with one big boy continent and one long boy continent. But okay, now let's take a closer look at each of these. First up, Tibet, or really the Tibetan Plateau, the Himalayas, the Tian Shan Mountains, and the Hindu Kush. Together, these mountain ranges and plateaus form the largest expanse of elevated land on the planet, covering a continuous area of roughly 3.2 million square kilometers, or about 50% bigger than Greenland. Of course, the bulk of this landmass is made up of the Tibetan Plateau, hence why I'm simply calling this whole thing Tibet. But perhaps its most distinctive or irregular feature is the Tian Shan Peninsula. To understand why these mountains appear nearly detached from the rest, despite being part of the same mountain building process, we need to think about how the crust would behave when being compressed. If we imagine the crust as a simple straight line, pushing on it from one end will cause it to deform upwards, producing the Himalayas and Tibet. But beyond that, it'll deform in the other direction, carving out a basin, followed by another smaller fold upwards, the Tian Shan Mountains. On a normal map, we can see these two ranges are in fact separated by the Tarim Basin. However, this is a little hard to see thanks to the fact that as rivers erode sediment from the mountains, all that soil gets deposited here, filling it up kinda like a lake of sand, to the point where it doesn't really appear as a basin anymore. But with sea levels drastically increased, the basin's lower elevation causes it to disappear while the mountains remain, and their relationship to one another becomes a whole lot clearer as their paths follow parallel lines, just like the ripples of a wave. Another interesting feature of this landmass can be found on its southeastern corner. Here, the Hangduan Mountains have been folded into a series of north-south running valleys, producing the three parallel rivers, where the Salween, Mekong, and Yangtze rivers run directly beside one another to outlets that sit thousands of miles apart. Each of these rivers has carved a tremendous canyon through their respective valley, which can clearly be seen when we raise sea levels, creating what would be some of the world's largest fjords right beside each other. The last real notable feature of this Tibetan landmass would be the peninsula formed by the Hindu Kush Mountains. Given the fact that this region is just barely hanging on to the wider landmass, I think it's safe to assume any plants or animals that lived here would experience a degree of isolation from the rest of the continent, behaving almost like an island, and would likely feature the most distinct flora and fauna anywhere in Tibet. As far as what the climate would be for a place like this, I must admit it probably wouldn't look anything like how I'm depicting it now. While the Himalayas would still likely trap moisture on one side, this would not have such an extreme effect as it does now, as being entirely surrounded by water would definitely help moderate temperatures and bring moisture deeper into the plateau. Though what exactly the environment of this land would look like is really impossible to say. Remember, with this much more water, who knows how thick the Earth's atmosphere would be, how much cloud cover there'd be, and by extension, how much heat gets trapped. And then there's alternate ocean currents to consider, which would result in different weather patterns, different monsoon cycles, etc. So to keep things simple, we're not going to get too deep into figuring out the specifics of our flooded Earth's environments. But at the very least, I feel confident in saying that because of Tibet's shape and size, it would more or less have generally the same climate. Sure, there'd be parts that are rainier and drier, but I think overall this would very much act like one continuous temperate environment. As such, many of the same animals would be found throughout, likely with a single class of dominant herbivores and consequently a single carnivorous group. The same, however, cannot be said about the Andean continent. And okay, hang on, seeing as this is no longer just a mountain range but a true landmass, it sort of feels wrong to keep calling it the Andes, and I feel a name like Andea is more proper. Andea's north-south orientation means it would begin in the tropics, pass into subtropical to a more temperate area, potentially reaching all the way into a subpolar zone. This would break Andea into a series of different biomes, starting with some sort of rainforest environment before entering the arid subtropics, where a desert would likely occupy. And by the end, the temperate zone would probably host some deciduous forest, capped by glacier-covered mountains, creating at least 3 distinct biomes. So while Tibet could be expected to have a pretty similar collection of animals across its entirety, forming a cohesive continental arena, Andea would more or less act like 3 consecutive islands, each one with its own array of creatures that add up to a much greater degree of diversity. By extension, being a smaller landmass, the animals of Andea or the Andeofauna would likely also be smaller overall compared to those of Tibet, the Tibetofauna, as any herbivores would have far more limited grazing areas, and consequently any predators would have fewer and smaller prey. This would be especially true for the northern jungle portion of the continent, which just barely remains connected to the bigger southern portion by a narrow isthmus, effectively isolating these northern forests from the central deserts, and in turn any temperate forests that may lay beyond. As a result, this biogeographical compartmentalization would surely lead to distinct plant and animal communities being harbored across this land. So, while India likely wouldn't feature as big or evolutionarily robust animals as Tibet, I have a feeling this would nonetheless be the far more interesting environment to study, at least in my opinion. However, with sea levels this high, we get to see a mountainous feature even bigger than either the Andes or Tibet take shape: the American Cordillera. You see, thanks to the divergent plate boundaries in the middle of the Pacific, oceanic crust has constantly been forced beneath the cratons of both North and South America for hundreds of millions of years. This has fueled a long history of mountain building all along the American coast, creating a semi-continuous chain of mountains from Alaska down through Canada into the Rockies, reaching Mexico and the rest of Central America before becoming the Andes, and even past that, forming the Trans-Antarctic Mountains in, Antarctica. While this can be hard to notice on normal maps, when we drive up sea levels, we'll start to see this feature take shape. And once we reach 2,000 meters, we'll find the Cordillera remains as the only remnant of the American continents. Despite having the highest peaks after the Andes, the Alaskan portion of this feature doesn't actually form all that large of a landmass, which I found surprising, and reveals just how densely packed these mountains are. Further down, we'll find the Canadian Rockies actually form an even larger collection of islands, despite none of them being as high as those in Alaska. Continuing on, however, we'll find the largest vestige of the American Cordillera besides the Andes to be the portion of the Rockies that fall within the United States. Here, the Sawatch Range on the east and the Wasatch Range on the west form two roughly equally sized landmasses, the biggest islands of this sunken earth, each approximately 150,000 square kilometers, as well as several nearby islands made from the Bitterroot Range, the Bighorn Range, and the Black Range. Altogether, this rocky archipelago appears far more chaotic than either Tibet or India, cluing us into the fact that these mountains are far older than the others, and as a result have had time to break down and erode, in doing so building up their surroundings. This has important implications not for terrestrial but marine life, creating a large area where oceanic plants could access both sunlight and soil, allowing these waters to harbor what would most likely be the most prosperous aquatic environment on the planet. Trying to come up with what sorts of animals would dominate in a geography like this, I can't help but think of how similar this looks to ancient Antarctica. As we learned in a previous video, it was this scattered island environment where penguins came to thrive 50 million years ago, having used their seafaring adaptations to take advantage of rich fish stocks while using the islands free from predators as nesting grounds. In a world like this, I find it perfectly feasible to think that a similar type of animal would arise to become the defining species of the ecosystem. The last big vestige of the American Cordillera can be found in what's today part of Mexico, the Sierra Madre Occidental Range. And okay, I'll be honest, I wasn't really expecting any part of Mexico to survive this flood. Maybe it's just because I'm an American, but whenever I picture Mexico, I either think of flat deserts like those immediately across the border, or the lowland rainforests found in the south where all the cool ruins are. I guess I was just forgetting about the whole middle part of the country, and in fact, taking a closer look, nearly the entire body of Mexico appears mountainous, explaining why so much of the country remains dry even after a 2,000 meter rise in sea levels. Looking around the world for other noteworthy islands, we'll find Europe has almost entirely disappeared, save for the Alps and the Pyrenees, forming two rather unimpressive archipelagos. Much the same can be said about Africa, where most of its highest peaks have also been reduced into tiny scraps of land, like the Atlas Mountains in Morocco and Drakensberg in southern Africa. The one exception here would be the Ethiopian highlands, which form a mid-sized archipelago clearly split in two. While normally this region appears as one big mass of mountains, looking at it like this reveals another hidden geologic process taking place, a divergent plate boundary. As the Somali plate tears away from the African plate, this has produced a massive rift valley running through the continent. Normally, the only real obvious indicators of this are the long and narrow lakes that have come to partially fill these rifts, but as we artificially raise sea levels, we'll see the mountains formed on either side of this valley begin to become isolated and better reveal what's happening beneath the surface. Of course, nowhere is this more clear than Ethiopia, where an entire plateau is being torn apart. Another landmass that's virtually disappeared is Australia. Currently, the tallest mountain on the continent is Mount Kosciuszko, standing only 2,300 meters high. This means a 2,000 meter rise in sea level puts basically the entirety of the landmass beneath the water, with Mount Kosciuszko persisting as little more than a small island. Ironically, by this point, there'd be more left of New Zealand than Australia, though that's not really saying much, and the only real substantial lands left in all of Oceania would be the mountains of New Guinea, which have become broken into a series of islands. After that, the only remaining islands to really talk about are back in Asia, where the Zagros, Elburz, and Caucasus Mountains form another very scattered archipelago. While I was again a little surprised to see so much of these mountains survive, if we look back in time, we'll see that the lands of Arabia remain firmly attached to Africa, and about 100 million years ago began to push into the Eurasian landmass. While this event wasn't nearly as forceful as India crashing into Asia, it nonetheless represents a collision between two continents, resulting in the substantial building up of these areas. Again, similar to the Himalayas, this mountain building event is ongoing, meaning every year these mountains grow higher and higher, or in this case would mean these islands expand to eventually form another unified plateau. And I think that's actually an interesting thought, how in a world like this, inundated with so much water, continents would be fleeting structures, emerging from the ocean and amassing a collection of flora and fauna, only for it to gradually erode away back beneath the water. This is different from the world we live in now, where the continents have been more or less continuous features on this planet for the entire history of life. In this world, the oldest major landmass would be the Rocky Archipelago, at only around 80 million years old, whereas the biggest continents would both be less than 50 million years old, far younger than the billions of years our continents have had. This rapid cycle of landmass emergence and submergence would in turn drive constant evolution and diversification in its life, generating lots and lots of new animals, very few of which would ever get the chance to persist after their homelands eroded away. And okay, while by this point I don't have much left to say about these mountains, there is one island here that I feel like is worth mentioning. If we look real close, we'll find this small, roughly circular one. This is Mount Ararat. While today this mountain mostly serves as a symbol of the Armenian people, it is perhaps most well known for being the mountain where Noah's Ark supposedly settled after the Great Flood as described in the Old Testament. And while I'm not trying to make fun of anyone's religion or anything, I do find it curious that even with drastically more water than the Earth even has, this and surrounding mountains still aren't underwater. Feel free to come to whatever conclusions you want about that. And by now I can feel you all wondering, when's he gonna talk about island biogeography? The thing is, I'm not going to. Sorry. In a situation like this, there's just too many variables, too many islands to talk about, too many questions as to how all this water got here, how long it's been here, that I don't think there's much I can say that isn't wild speculation. But I will say this would be a crazy fun planet to study, given how isolated each of these lands are from one another. So I'm giving you all some homework. Look back at the places in this video, pick your favorite one, and try to come up with your own ideas about how life would evolve or adapt here. I'll be posting high-resolution pictures of all of these places on my Twitter, as well as a map of the whole world. So make sure to find me over there and share what you come up with. Ultimately, while an Earth like this could never exist, at the very least, I believe I've shown that depicting it in this way is still a useful tool for learning about parts of the world that would otherwise remain hidden in plain sight. Hey everyone, I hope you enjoyed. If you did and want to see more videos like this where I look at the Earth with varying sea levels, make sure to give this video a like. Also, let me know how much water the Earth should have next time. Should I add even more water or take it down to only 1,000 meters? Of course, if both of those sound like videos you'd watch, make sure to subscribe because they'll both get made eventually and you don't want to miss it. Lastly, if you want to be a part of what gets these videos made, you can check out my Patreon and help support me and the channel. Thanks.